I will discuss Kannada recognition and OCR development on Kannada. One of the topic which I discussed today is Kannada whole modifier recognition. Throughout the presentation, these are the topic which are going to be discussed. There is a detailed discussion on Kannada script itself and the architecture for the recognition which is developed in this research work is discussed. Segmentation of Kannada Akshara, which makes a lot of challenge during this research work, is further explained. Gabor filter and related procedure to extract filter for feature extraction are further elaborated. Gabor bank and how to create the Gabor bank are elaborated in the presentation. The experimental result and the conclusion is covered later. The result which are produced in this research are published in three major international conferences and later they appear in Springerling, also in two IEEE publications, uh, 1 and 2. All these are related for the whole modifier recognition, and the whole modifier itself uses two type of segmentations. There are several applications which are present for optical character recognition, such as license plate recognition, which is used for parking slots and also used to recognize the car on the roads, and retrieving the information from the book. If it is a old and it has so much wealth of knowledge, OCR playing a lot of important role while extracting the information from the books. Also, they are extensively used for engineering drawing recognition. Translating and speech recognition is another area where OCR has found application. A survey on OCR system for Indian languages is presented by U. Paul in the paper of Indian Script Character Recognition, a survey. In comparison with the European language such as English, many of the Indian languages are more complex. They have large character set. This is an example of basic character set which are present in Kannada. In Kannada script alone, there are 19,090 character, or they are also called as Akshara. Many of these character in Kannada script have similarity in shape. Because of the similarity in shape, the recognition task of OCR is much more complex and challenging. Now, these are the example of basic character which are present in Kannada. These are called as vowels, and these are the consonants of Kannada characters. Along with these, there are some kind of modifier. Many of these vowel have their modifier. They connected with usually one of the consonant to create more further different type of aksharas. Thus, a large set of akshara is created by combination of basic symbol along with the basic consonant and other form. How the consonant conjuncts are combined with consonants to create more compound characters are explained below. These are the basic consonants, and there are consonant conjuncts corresponding to each consonants. So these are the consonants, they are combined with consonant conjuncts to create more compound aksharas. These are the examples. Here simple consonant is combined with an vowel, then followed by consonant conjunct. Usually consonant conjunct are appear at the right side bottom as shown below. They may not be directly connected to the earlier consonant, but they may be occurring as an independent component in the akshara. So how do we go for performing a recognition if the data set is huge and complex, which are created, the aksharas are created with a combination of various class. One way is to go for character level segmentation. So this is the approach which is used in this research. What do you mean by segmentation? There are various level of segmentation. First comes the independent component isolation. If the component of the akshara is independent, it is not connected, we can easily isolate those component as given in this example. There are other segmentation which are carried out in this research. One, it is called as top level segmentation. If the akshara has both the top portion and middle portion, the top segmentation is carried out. So after performing the top segmentation, we get the top portion of the character, and the middle portion is extracted separately from the character. Then there is another type of segmentation. If the character has both top as well as right side portion, then we go for the top as well as right side segmentation. It is also called as right side segmentation. So after extracting, we will get top portion, middle portion as well as right side portion from a character. There are Gabor filter which are used to perform this character level segmentation. So what are these Gabor filter? Gabor filter is basically a sinusoidal wave modulated with a Gaussian. The various type of Gabor filter can be designed with the help of changing the angle as well as the sharpness and the frequency. With the help of these parameters, we can generate a large number of Gabor filters. There are Gabor filter provides the response based on the frequency and the angle for which we have used. This is an example of application of a Gabor filter on a Akshara. Usually we have taken this one with the angle theta as 0. So and the higher frequency we utilized in order to extract some of the components from the given Akshara. You can see there is a highlighted area, which is because there is a two mark that are present in this particular Akshara. Similarly, if we apply the Gabor filter at the different frequency, we will get the different responses. And this is this concept we utilized to perform character level segmentation. So the segmentation is effectively to identify a threshold point or a point along which it could be divided, the Akshara could be divided to extract the required portion. So it is important to identify the exact index along which we perform the segmentation. In this case, it is called as horizontal index. In the next level where we would like to perform the right side segmentation, we try to identify the vertical segment. The horizontal as well as the vertical segmentation point are identified from the Gabor. This is the architecture which is developed in this research to perform the vowel modifier recognition. Initially, the input of the Akshara in the form of the image is given to this architecture. This is an example of image. You can also see this is a complete Akshara which consists of two independent components there. Later, after the size normalization, independent component identification is carried out, where if the portion of the Akshara is not connected, they are separated out in two different components. The independent modifier recognition is carried out. This is the portion of independent modifier which is further perform recognition using artificial neural network. Later on, the segregation of the Akshara is carried out based on the width. If Akshara has both the right side and top portion, then its width is greater. Therefore, it is further given to top as well as side, right side portion segmentation. If Akshara has only the top portion, then its width is lesser. Then the top portion segmentation is carried out. These are the example of top portion segmentation. After the segmentation performed using the Gabor filter based method, the top portion is recognized using artificial neural network. Then the right side portion and the top portion segmentation is carried out, resulting in three different portions. One is top portion, middle portion as well as right side portion. Top portion and right side portion are further perform the recognition using artificial neural network. At the last stage of the architecture, the class level integration is carried out. The class labels which are predicted at the level of independent modifier, top portion recognition level as well as right side and top portion recognition, all the class label are integrated at the class level integrator. and the result of this class label integrator is the whole modifier class label. Now there are several number of independent portions which are present in the Kannada script. There are six different whole modifier, and we developed artificial neural network to perform the recognition of these independent portions. And now discussing about the top portion, there are five different type of top portions which are present in Kannada. Each top portion also result in a variation due to the consonant portion is connected in whole modifier in different way and resulting in different shape. For example, this particular type of top portion resulting in different variations as shown in the figure here, and this type of top portion is resulting in different shapes. So this is the main challenge when we performing the top portion recognition task. There are several right side portions as well. When the akshara is connected to whole modifier, then it will lead to some right side portion. These are the right side portion. Mainly there are four different type of right side portion. We need to develop artificial neural network to perform this particular right side portion detection. At the last stage of the architecture is performing the class label integrator. The task of the class label is to receive the class prediction that are done at the level of independent modifier, top portion and right side portion. And finally, the class label integrator queues the output as whole modifier class label. We use the Gabor filter based feature extraction technique to perform the feature extraction on the various portion of aksharas. The Gabor filter with the different angle and frequencies are used, and the responses which are generated from the Gabor filter are used to collect the directional feature. So we use the grid system to extract some directional features from the response. So this is one of the grid system which is shown in this figure. Gabor filter bank is created. Gabor filter bank for independent modifier are created with a different angle and the frequencies. Similarly, there are several set of Gabor filters are created for top portions and right side portion. The angles and the corresponding frequencies are shown in this table. Experiments are conducted on the database that is generated using the Barha multilingual editor. Various fonts are considered to create the text. These are Barha Kannada, Barha Bengaluru, Barha America Kannada, Barha Kasturi, Barha Sri Kannada, and Barha Vijay. These are the various fonts which are present in Barha multilingual editor. Using these different type of fonts, we generated a large number of multiple pages and used these multiple pages to scan using the HP laser jet. By scanning this, we generated a Kannada data set, and the data set includes around 10,771 character. Out of these, we utilized 4,200 akshara to perform the whole modifier recognition. These are the classification which are carried out. Initially, the classification rate corresponding to independent modifier are shown. As I already told you, the artificial neural network is used to perform the recognition of independent modifier. So this is the topology of artificial neural network. The input layer has 55. The number 55 depends on the how many number of directional features are extracted using the Gabor filter. There are four different number of layers are used. At the last, six number of output layers are used because there are six classes are present in independent modifier. Similarly, for the top portion, we use the topology consisting of input layer as 60, then later on 40, 20, and 4 is the number of neurons in output layer. And right side portion also there is a topology with four layers, and input layer consists of 64 and the output layer consists of three number of output nodes. Recognition of vowel modifier is finally done because of the class level integrator, which integrate the various results generated at independent modifier top portion as well as right side portion. Now you can see there are 16 different vowel modifier. It also consists of some connected portion, and there are some independent portions as well. So we utilize three different neural network to carry out all these three portion recognition. At the later stage, we integrated using the class level integrator. Now this is the classification rate which are achieved using the artificial neural network and the class level integrator. You can see the classification of 93.8 percentage on the 10-fold cross validation is achieved, and highest is around 98.61 for this particular whole modifier is achieved. In conclusion, Indian language consists of large collection of character, making the recognition task very difficult. Kannada language itself has large collection of character which are formed by combination of basic symbols. Whole modifier recognition is explained in this presentation along with an architecture which is developed. Also explained the results of this particular research are presented in three different papers. Artificial neural network and Gabor filter based technique are used to perform the recognition. We developed a system, and on 10-fold cross validation, a overall recognition rate of 95.04 is obtained. Thank you for listening this presentation. I hope you enjoyed this presentation. Also found some insight in the on the topic of all modifier recognition. Thank you.